Okay, it's 10:30 now. Then let's start today's seminar. Today is the 562nd weekly Oceans Weekly Seminar and the 167th International Seminar. Today, the paper that we will present is on derelict fishing gears in relation to the characteristics of coastal fisheries in Taiwan. And the presenter is Yanning. Yanning, the floor is yours.
Okay, wait a minute. Okay, good morning, everyone. So today I will lead this seminar, and the paper is derelict fishing gears in relationship to the characteristic of coastal fisheries in Taiwan. The paper is quite new. It's just published this June or July. So here is the abstract. Okay, so here is the abstract. So they use the data set from SOW. So the data set contain 1,037 beach cleanup from 2009 to 2018 across various counties and cities in Taiwan. So this paper wants to understand the marine debris hotspots, and they focus on the derelict fishing gear. So they put derelict fishing gears into 3 groups: floating items, fishing gear, and tackle items. And they found out floating items is the most, is 59%, and fishing gears 25%, tackle items is 16%. And they use a GLMM to identify the most influential factors of all these 3 derelict fishing gear types. So they found out the average tonnage of boats and the boat number of net type are the 2 most influential factors. So here is the abstract. Okay. Okay, so the objective of this paper is to analyze the composition and hotspots of derelict fishing gears along Taiwan's coast. And as I mentioned earlier, they use GLMM. The generalized linear mixed model is a statistic tool to understand the random effects of different factors, and they want to understand the relationship between fishing activities and derelict fishing gears. So they use many factors relevant to fishing activities. And they also want to understand the types of derelict fishing gears and the reason for derelict fishing gears generation in each fishing port county in Taiwan. So this is the objective of this paper. So I can give you a brief context of Taiwan's coastal fisheries. So we have more than 200 fishing ports across Taiwan Island and also the outlying islands, and mostly they are small-scale coastal fisheries. So the coastal fisheries, we have more than 12,000 motor vessels, and also 13,000 rafts. So you can see the photos at the right-hand side. So you can see mostly this kind of small-scale fishing vessel, mostly below 100 tonnage. Okay, so because our geography and landscape is diverse, so the fishermen, they have mixed use of fishing gears, so including nets, traps, long lines, and also some marine culture. And oyster aquaculture is the domain marine aquaculture. So as I mentioned earlier, we have diverse coastal geography. So we have diverse fisheries and also diverse of fishing gears. Okay, so here is a brief context of Taiwan's coastal fishery. And here is like a simple, I put their research process into a diagram so you can understand better. So they use the data set from 2009 to 2018, and this data set is from Society of Wilderness, SOW. They are the biggest environmental NGO in Taiwan. So they are also the first to encourage everyone to go to beach cleanup, and they set an online data set. So they have accumulated like more than 10 years of beach cleanup data. So this paper used the data from SOW's data set, and they retrieved 1,037 beach cleanup records. And the research team, they set 11 fisheries variables because they want to understand this derelict fishing, the relationship of the derelict fishing gears and the fisheries activities. So they set 11 fisheries variables, and they use GLMM models to find key drivers, means which factors are the most influential ones. So so you can see the diagram below. So they retrieve the data from the SOW data set, and they use the 11 fisheries variables into the GLMM models, and they try to find out the factor with the largest AIC number. That means it is the most influential ones. Okay. And here is the materials and methods. So here is the data collection. So as I mentioned earlier, they use the data set of SOW from 2009 to 2018. And the coastal marine debris is categorized into plastic, disposable fishing equipment, and others. And among the derelict fishing gears, it was classified into 3 groups: fishing gears, including nets, ropes, etc. Floating items such as plastic or styrofoam floating buoys, and tackle items is more like recreational fishing gears, including fishing rods, hooks, rigs, etc. Okay. And here are the 11 fisheries factors. So because the research team wants to understand the relationship of derelict fishing gears and the fishing activities, so they put various fisheries how to say the numbers relevant to fisheries activities, such as fisheries employment population, landing, boat number, port number, etc. So you can see table 1 for more details. So here are the 11 fishing factors. So they use the data set from fisheries agency and also Ministry of Labor to retrieve these numbers. Okay, so they will use these 11 fishing sector into the GLMM models later. Okay, so I won't go to the detail of this table, but you can see they put like many factors that are relevant to fisheries into their statistic model. Okay, so here is the GLMM model. So the research team, they use GLMM models to evaluate 3 types of derelict fishing gears, including fishing gears, floating items, and tackle items, and estimate the effects of 11 fishing sectors on DFG accuracy. So you can see the formula below. So so they put the 11 fishing factors and also the beach cleanup factors into the same model. So GLMM is a statistic model that extends generalized linear model that includes random effects. So in addition to fixed effects. So this approach can allow for a more flexible analysis by accounting for variations in the data that may arise from different years, regions, and other random factors, thereby improving model accuracy. So the fishing sectors associated with the largest AIC increase was identified as the most crucial contributor to the specific type of DFG. So this approach can let the research team to identify the most influential fishing sectors for each type of derelict fishing gears. Okay, so here are the results. So this figure is generated from the SOW data set. So you can see the data is from 2009 to 2018. And 2016 is the year with most beach cleanup activities. And you can also see the number of marine debris. So before 2015, the number is not so many, but after 2016, it's like a peak, and the pink line is derelict fishing gears. So you can see among the number of marine debris in this data set, you can see derelict fishing gears is not like abandoned items in this data set. Okay. And here is the city that have a beach cleanup. So you can see New Taipei City, Keelung, and Yilan. They are the place with the most frequent beach cleanup. So as how to say that, these three places, because it's all very close to Taipei City, which is the capital city and also the most population concentrated area. So I can see why these three region or county has the most frequent beach cleanup activities, especially New Taipei City, because the coastline is very long and it's also very close to Taipei City. And also Keelung, the coastline is very, very short. It's less than 20 kilometers, but because it's so close to Taipei, so many beach cleanups are held there. Okay. Okay, so here is the composition and proportions of marine debris from the SOW data set. So you can see the plastic products is like 44%, and disposable items 22%. So more than 60% is like the single-use plastic items, and fishing gear is 14%. So from the data set, you can tell that fishing gears is not very abundant in this beach cleanup, and this is related to the characteristic of this of their beach cleanup. So I will talk more in the discussion part. Okay. Okay, so here is the spatial distribution and composition of marine debris and derelict fishing gears across Taiwan's coastline. So we can see the figure at left-hand side. So you can see the blue part means the plastic products. So mostly the plastic products is like the most like 40% to like half to 50% across Taiwan and also Penghu. And they also calculate a number called amount of marine debris per kilometer items, PKI. So they identified Keelung, Hsinchu, Taichung, and Kaohsiung. So these 4 cities, I use a orange box to mark these 4 cities. So so the research team identified these 4 cities because they have the highest amount of per kilometer items, around 8,000 items per kilometer. So it's really high. And the right hand, we can see the figure at right hand side. So this figure is the distribution and composition of derelict fishing gears across Taiwan's coastline. So you can see Penghu, Taichung, Hsinchu, and maybe Tainan has most the circle is bigger than others, and the floating items are also much more than other counties in these 4 counties: Hsinchu, Taichung, Penghu, Jiayan, and Tainan, also Kaohsiung. Okay, so the research team in the discussion part, the research team, they discuss about the oceanography. So as you know that in the east side of Taiwan, we have crossshore current from Philippines and up to Japan. And the crossshore current, the speed of crossshore current is very fast. So usually at the eastern part of Taiwan, we don't have much marine debris because usually the current just bring the debris up to north. And also because of the geography. So at the east side of Taiwan, the geography is very steep. So at the coastline, the distance of the coastline and the continental shelf is very close. So the geography is very steep. So usually there is no flat shoreline to accumulate marine debris, unlike the west side of Taiwan. The east side of Taiwan, the geography is very steep, and also the crossshore current is very fast. And at the west side of Taiwan, this side are the most Taiwanese population concentrated area. So more cities in the western side, and also the tidal difference is huge, and also because the geography is more flat. So usually a lot of marine debris will accumulate on the shoreline after typhoons or raining events. And also there are more marine aquaculture concentrated at the southern western Taiwan. So you can see there are much more marine debris distributed at the western side of Taiwan. Okay, and here is the quantity of fishing debris per unit kilometer in Taiwan's counties and cities. So so the research team, they separate the derelict fishing gears into fishing gears, floating items, and tackles items. So here is the list of city, and they want to understand like hotspot for each type of fishing gears. So I think in the article the authors made a mistake because it says New Taipei City is the lowest with the lowest derelict fishing gears, but in fact is Taidong, and the place with most derelict fishing gears is Penghu, is like more than 900. So I think in the article the authors made a mistake. They put a different name of it. So we can see at the fishing gears, Keelung, Kaohsiung, and Penghu are the cities with most fishing gears, and the floating items, Penghu, Tainan, and Taichung. So Tainan is the place with most marine oyster aquaculture. So I think Tainan, this one makes sense. And Penghu because there are many floating buoys from China. So I think this figure also makes sense. For Taichung, I'm not quite sure because Taichung is not a place for oyster aquaculture. Actually, in Jiayi, they are the place for oyster aquaculture, but maybe because there are very few beach cleanup held in these cities. So in this table, they didn't reflect the true situation of Taiwan. And the take-home items, they list Keelung, Hsinchu, and Taichung. So the research team think that because this place, there are more recreational fishers like to go fishing in these 3 counties, so they have more tackle items than other cities or counties. Okay, so this figure is from the supplementary material. So they put the fisheries data of each county. So the y-axis is the name of each county, and so you can see they put the different fisheries data to compare with the situation in different counties. So I will not go to details of these figures. So you can see the research team also make this figure. Okay, so here comes to the GLMM model. So as I mentioned earlier, the GLMM is a statistical model to identify the most influential factors. So the research team, they have list 11 fishing factors as the variation. So they use their step is like this. They use the initial model with all variables, and they generate the AIC of 113, this number. So they use backward stepwise selection. So they literally remove a variable and to test the number of the AIC to see if the AIC decrease. And sorry, I made a mistake. So they decrease a variable step by step. So when they decrease when they decrease 6 fishing factors, they have this model, the model in pink, and they have the number of AIC 113, and they think this one is the best. This model can best explain the variation. So they think this is the best model. and they use this model to test which fishing sectors is the most influential ones. So when the research team keeps removing these influential fishing factors, the ATB, the average tonnage of boats, emerge as the most influential factors, showing a positive relationship with the amount of fishing gears. So, so what does that mean? So when they remove ATB, when they remove ATB from this model, you can see the number increase significantly from 113 to 134. So this means ATB is more influential, because when it removes the model, you can see the number jumps a lot. So they identify ATB is the most influential ones. So they use this step to test also other two derelict fishing gears. So, okay, so we can see the figure here. So they want to understand not only which one is the best model, they also want to understand the relationship with the amount of DFG. So here, the three figures in pink ones. So these three pink ones, you can see the trend is positive. So that means they have these three fishing factors have positive effects on DFG. So the here, average tonnage of boats, net using boats, and also fisheries employment population, they see when the number increase, the trend also increase. So they can see these three fishing factors has positive effects on the derelict fishing gears. So here is their assumption. So when there is higher fishing intensity, maybe it will lead to more gear loss. And compared to the other two fishing factors, the port number and the miscellaneous boats. So these two, you can see when the number increase, the trend goes down. So they have negative effects on the derelict fishing gears. So the assumption is maybe because when the boats, they are like they target different species, and this kind of diversified fisheries will reduce concentrated gear loss. So here are their assumptions. So the research team repeat this step to review all the fishing factors. So here is the summary of their GLMM model result. So we just see the first one on the fishing gears. So they identify the average boat tonnage and the net using boats, and also fishing effort proxy. They have they are positive influence on the derelict fishing gears. So on other two type of fishing gears, the floating items, they identify the total boat numbers and the average boat tonnage. They are more influential ones. For the tackle items, they identify the average boat tonnage and the net type boats. They are more influential ones. So overall, you can see the average boat tonnage, ATB, appear in the three sections, and also the net using boats appeared in these two sections. So the research team regard these two factors, the average boat tonnage, ATB, and net using boats are the most two influential fishing factors when they want to discuss the variation, the influential effects of fishing sectors. Okay, so here we come to the last part, the discussion and research limit. So from the SOW data set, they found out the derelict fishing gears occupies 14 of Taiwan's marine debris. So this number is higher than Australia and Israel, but is similar to the neighboring countries such as Japan and South Korea. And the research team also spent some paragraph to discuss the spatial distribution and characteristic of derelict fishing gear types in Taiwan. But in this part, I somehow feel they forget or they ignore the limits of the SOW data set, because for me, the SOW data set couldn't reflect the overall situation. We see there are like 3 cities or counties has very high beach cleanup effort in New Taipei City, Keelung, and where I forgot, and Yilan. But these 3 counties means they are very close to Taipei City, and they have a flat and long beach that easy to access and very suitable for families, especially for students and kids to do the beach cleanup. But this high beach cleanup effort didn't equal to the high amount of marine debris. So in the same, following the same logic, the counties with no data or with very low data doesn't mean that that beach is clean. So I somehow feel the research team, they forget or they ignore this research limit, and some part of their discussion, I feel is that true? Is that the true situation in Taiwan? Or I feel it's very difficult to explain the real situation in Taiwan's shoreline. So I didn't put them into my presentation because I want to discuss the research limit by using the only one data set in the research, but they didn't discuss the limit of the data set. I feel it's not suitable or very solid scientific evidence. So that's my that's all from my sharing. Thank you. Do you have any questions?
Thank you, Ning. The presentation was really very interesting. Thank you.
Thank you.